Hello and welcome back to Precalculus1, section 7.2, Systems of Linear Equations in 3 Variables. So generally we want to have the number of equations to match the number of variables, and we can calculate if the solution exists. Obviously we can calculate the solution. Now, having 2 equations in 2 variables would be the 2 lines on the plane, right, on xy plane. And then we have those 3 cases, intersect or not, and so on. Now, the world is much richer because we are moving from 2 into 3, which means third-dimensional space. Now, the concepts of all of this, the application of this are all in Calculus 3. So we don't need to work on it. But it's not bad to mention that you are actually working with equations that represent planes. So if you take a look at the wall, or the ceiling, the floor, those are what we call planes, the flat surfaces. And the plane can, so I'm not talking about airplane, I'm talking about a plane. So plane could be oriented in any way. You have the surface of your desk, you have the surface of your screen for the computer, surface of your cell phone. Those are all planes. And as you can see, you have a plane over there, that wall, and you have a plane behind me, which is a wall, and you have a plane on top, which is a ceiling. And all of those 3 planes intersect in a corner point. So that point there would be the solution for intersection of those 3 planes. So if you're trying to place this geometrically, the way we did with the lines, now you have to work with planes. Now all of the equations and calculations for that kind of stuff, as I said, it's all in Calc 3, so we don't have to worry about those types of concepts. What we worry about is how do we get x, y, and z values, right? How do we compute those values if the thing is given to us, like the 3 equations. So let's start with the system. X plus 2y minus 3z equals 9. 2x minus y plus 2z is equal to negative 8. And negative x plus 3y minus 4z is equal to 15. So there's your system. And if there is a unique solution for it, then x is equal to a number, y is equal to a number, and z is equal to a number. Just by looking at the system, you can see that the solution is 1, negative 2. Sorry, negative 1, 2, negative 2, but that's fine. We'll come up with that eventually. Yeah, I read that. So let's see the method. Number 1, pick which variable you want to eliminate. Oh, no, so substitution here, just elimination. So pick which variable you want to eliminate and stick with it. So pick which variable you want to eliminate and eliminate it from all 3 equations. So say I pick x. That means that I will have to eliminate x in all 3 equations. And I can only do that 2 equations at a time. So what I'm going to do is I'm going to have a red pair of equations, which is, say, x plus 2y minus 3z equals 9, and 2x minus y plus 2z equals negative 8. And the blue pair of equations, I'm recycling the first one. So x plus 2y minus 3z equals 9. And the last one, negative x. So you can pair any equations you want. Obviously, one equation will have to repeat itself. And in this case, it's the first one that repeats. It doesn't matter. I could have picked any combination of any of them. So I picked the first two and then first and the third. But you can also pick these guys if you want to. And now, all you need to do is to eliminate x in both of these sets. There I say clearly, you need to multiply by -2, right, to eliminate red x's. And you just need to add on the blue side, because x's are immediately gone as soon as you add these values. So, I have -2x, -4y, positive 6z equals to -18. And then I'm copying the bottom equation because I haven't done anything to it yet. And now, when I have them as opposite signs on x, when I add, I get -5y plus 8z is equal to -26. And now we jump to blue one. I just add. Becomes -y minus 7z is equal to 24. Observe what you have. A red equation and a blue equation, but those equations, guys, are the previous section. You reduced the 3x3 system into 2x2 system. So now all you need to do is to solve this new system that it's much easier. -5y plus 8z equals -26, and -y minus 7z is 24. Plus 3y. Plus 3y on the blue. Well, luckily it didn't destroy everything. I mean, it would ruin everything. So he makes it 5. Ooh. That makes it a 5y. Nice. Well, y's are lined up for elimination. And look, z is -2, as I have foreseen. Okay, great. So now you use z in any of the equations of these black equations here to come up with y, and then you have z and y to calculate x. So let's use the bottom equation. It says 5y minus 7 times -2 is equal to 24. So that's 5y plus 14 is equal to 24. 5y equals 10. Y equals 2, as I have foreseen. You can use now first equation if you want. I believe first equation had the smallest numbers. Or no, maybe second equation. Yeah, whatever. X plus 2y minus 3z. So x plus 2y minus 3z equals to 9. That's x plus 4 plus 6 equals to 9. X equals -1. Yay. So -1, 2, -2. And that will be the solution. What happened? It's very systematic. Pick whichever variable you want to eliminate. Create two groups of equations. Eliminate that particular variable for both groups. That will give you a 2-by-2 system. Eliminate another one of the variables. So do the substitution, whatever works. And just go step by step back to calculate the others. Believe it or not, that's it for 7.2. There are no further things. So let's do more examples. The book explains, one problem per page, per 10 pages, but they really explain it in detail, so you should look it up. We have x plus 4y minus z equals to 20. 3x plus 2y plus z equals 8. And 2x minus 3y plus 2z equals to negative 16. So, which variable we should eliminate in this case? Z. You can pair, right? You can pair up easily. If you pair the first two equations, you don't even have to touch it, just add. And then first and the last one. Yeah. Oh, too hot in the hole. Anyone has tears there? Smiling, no happy. We're going mad over here. Look at this misery, this sweat. Look around. This is much better. Was coupled with some agonizing screams. You're hearing the hellfires in the background and stuff, right? We're solving equations. There we go. Now we go. Okay, so as you can see, I found this equation, and I immediately divided it by 2 because I noticed that all of the numbers are divisible by 2 to reduce it. But now I see that I need 4x back. Right, such is life. So instead of, so I'm just going to cross it out because I really need my 4x back. Now, you don't have to multiply by -1. What you can do is you can simply subtract equations. That's okay as well. You can go and say subtract. That works as well. So 4x minus 4x goes away, and we have y equal 4 immediately. Now I can use the simplified equation 2x plus 3 times 4 equals to 14. 2x equals to 12. X equal to 6. So that's another one. And then bring one of the z equations. Maybe the first one. X plus 4y. So x plus 4y minus z equals 20. Get in the habit of crossing your z's, because they're going to look like 2's and eventually can make a mistake that way. So 6 plus 24 is 30, minus z equals to 20, so z is 10. And the answer is 6, 4, 10. As the ordered triplet, x, y, z. Happy? What happened? Another one, of course.
Yeah, I got the same.
Oh, that's a 2. Why don't you say so? Well, that's a 1. That's a 1. So that's a 17, right? So that's not a 10. That's what I said. No, I was just making sure you're paying attention. Good. Good. I'm happy you're paying attention. Okay, let's do one for real. So this last example is probably going to be the easiest of all, because one of these values will already be missing. For instance, problem number 12 from homework, and pretty much all the rest of the homework. So x plus, and then z, there's empty space there, is 3. And then x plus 12y, no, 2y, minus z is equal to 1. And 2x minus y plus z equals 3. What should you eliminate? This one is already 2 variables. So get rid of y's and you're done. Right? If you go with z, you have to make pairs again and do all the work. When one variable is missing, go and eliminate the rest of that variable, because half of the job is already done for you in eliminating that variable. So just multiply the bottom equation by 2, kill the rest of the y's, right, from second and third equation, and combine it with the first, you're done. So over here I have x plus 2y minus 1. Yes. You can do substitution, yes. So at this step where you have 2 by 2, if you have symbols, you can do substitution if you like it. But I like the substitution. The sum means subtraction because it's quick. 5x minus x, 4x, and then z minus z is gone, 7 minus z is 4, and then done. But you can use sub. Another one? One more. All right, one more. Deal? And then what? I can't have differential equations. You know the rule in my class. You can leave at any point. So can I make this hard? Or can I? No, of course not. Can I make it annoying? Ah, now we're talking. Look at this beautiful problem. It's going to take about 2 days now. 17. 3 open parenthesis 2x plus y plus 5z is equal to negative 1. 2 open parenthesis x minus 3y plus 4z close parenthesis equals to negative 9. And, oh, you're going to love this. 4 times 1 plus x is equal to negative 3 z minus 3y. Beautiful. So just multiply everything out and move to the left, and that's it, right? So it's annoying, right? But and I will be eliminating y. Why? We can also eliminate x. We can pair x this way as well. What did you eliminate, x or y? Not that no one went z. So since some of you eliminated x and some of you eliminated y and no one eliminated z, you got this, right? You just need to polish it. So I need to multiply the top equation by 2. So I get 12x plus 6y plus 10z negative 2, along with 2x minus 6y plus 8z negative 9. And then I need to multiply top equation by negative 3. So I have negative 18x minus 27, no, minus 9, y minus 15z is equal to 3, and 4x plus 9y plus 3z equals to negative 4. These cancel. 14x plus 18z is negative 11. These cancel. And negative 14x, ooh, nice, minus 12z is equal to negative 1. So now when this one goes here, and I add them, 6z is equal to negative 12, z is equal to negative 2. You have a fraction? Does anyone have negative 2 on z? Like this. Negative 18. Where do you see negative 18?
Negative 18, x minus 9y minus 15z.
Oh, when I multiply the top equation by a negative 3. Because I have positive 9. So negative 3, negative 18, negative 9, positive, negative 15, negative, positive 3, and then I copy this equation, and when I add them...
If you get positive 9, then shouldn't it be 9?
No, but then it's negative 1.
But that means for...
Yeah, because negative 9 over
That could be wrong.
Over here?
Yeah.
I copied because...
No, the last one. The big one.
This one?
Yeah, that's it.
Negative 9?
Yeah, because negative 3 times negative 3 is positive 9. So when you move it to the left, you're going to subtract it, so that should be negative 9. Negative 3 times negative 3y should be positive 9y. And then when you move it to the left, it should be a negative 9y.
Yep.
Yeah?
Rip. That's a negative.
There you
Ay, 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 ay.
Come on, this is the one thing that I got like solid.
You have 18z, right? And negative z-ben.
Yes. It should be 14x plus 18z equals negative 11. Yeah.
Is this what everyone has now? So no solution, yay. I think. Because we have 14x and 18z, and 14x and 18z, they have the same signs and different numbers over here. Why?
Oh, that one, yeah, that one's something.
Yeah, one is negative 11 and one is negative 7. Where? Oh, I changed the sign. I didn't change the x. Ah, I can't. Yeah, we're done. It's 22x. So now we subtract, right?
Yeah.
Let's go 2 minus 1.
Yeah.
8x minus 7 plus 11 is 4. X is 1/2. And he left. So you have the same?
I have 1/2, yeah.
All right. Okay, so going back to the origin. So what I did wrong is I got this sign here wrong. And instead of getting 1/2, I got 2 for z. So now when I fix that sign, that changes stuff. This part stays the same, but this stuff changed. So this part here is the first equation and the third equation to eliminate y. So you have a 3 and negative 9. So I multiply the top by 3, which is 6 times 3 is 18, and right? (18 plus 18 equals)
It's like 14x plus 18z equals -11 at the bottom. Then 22x plus 18.
Well, let's do one at a time, because you know what? We have time. I mean, you have nowhere to be, right? You all had a relaxing weekend, so I'm done with trying to fix stuff. So, from scratch, I'm not going to erase the course, so it's not going to be 1.1 now. We're just going to do from here, where we all agreed that this is good. We're going to start from here and just finish off so it's easy to follow without patching it. I am eliminating y's because 3 and 6 work nicely and 3 and 9 work nicely. I can also eliminate x's. The first time around, I'm going to multiply by 2 and eliminate the first 2 rows. So that's 12x plus 6y plus 10z is equal to -2. And copy the second row as is, which is 2x minus 6y plus 8z is equal to -9. And when I add them, the y's eliminate, and I have 14x plus 18z is equal to -11. And that's where we leave it. Now, so that was equations 1 and 2. Now we're going to equations 1 and 3, because we want to use 3y and 9y. I need to multiply by 3, so that's 18x plus 9y plus 15z is equal to negative something, -3. And third equation, copy as is, so 4x minus 9y plus 3z is equal to -4. So now that's 22x plus 18z is equal to -7 when I add the equations, because we have opposite signs. So now I will write this equation underneath. So 22x plus 18z is equal to -7. And I will subtract equations, equation 2 minus equation 1, to get 18 minus 18 on z, right? So equation 2 minus 1, so 22 minus 14 is 8x, z's cancel, and then equals to -7 plus 11, because we are subtracting. -7 plus 11 is 4. So x is equal to 1/2. So now that I have that x is equal to 1/2, I can use any of the two equations to come up with z. Let's use 14 times 1/2 plus 18z is equal to -11. Half of 14 is 7. Move to the other side, we get 18z is equal to -18. So z equals to 1, -1. And now we have x, we have z, so we can use those two to come up with y. For y, you can use any equation that you like. Let's use the first one. Yeah. So 6x, so that's 6 times 1/2, plus 3y, and then plus 5z equals to what? -1. So that's 3 minus 5 is -2, plus 3y is equal to -1, plus 2, so 3y is equal to 1, and y is equal to 1/3. So 1/2, 1/3, and -1 is the solution. I know. Fun stuff. I will see you all in 2 days, and we're going to do more fun stuff. So this is very systematic, guys. Just one thing at a time.